Like terms are terms that have the same variable. So that's the letter part, an x or a y or an a, raised to the same exponent. If they're different variables, they're not like terms. If they're taken to different powers, so they have different exponents, they're not like terms. Okay, and we'll look at more examples of this and what it means as we move on. But just know that like terms have to have the same variable. So they have to, both have an x or both have a y. And those variables have to be taken to the same exponent. Okay, so either just x or x squared or x to the third. The other one also has to be x squared in order to combine the terms. Yep. Cubed is the third. Okay, constants are like terms. So a constant is just a number without a variable. So like 1 is a constant. 10 is a constant. 47 is a constant. It's just a number that doesn't have a variable with it. Constants are like terms because we can combine them to simplify. Okay?
So just like 128 is a like term?
It's a constant. And it could be combined with another constant like 7. Right? Because they're both constants.
Yeah.
Okay? It'll make more sense as we keep going through. Don't worry. Let's sharpen our pencils before class starts, please. All right, terms. So we talk about like terms, but we need to know what is a term. A term are parts of an expression that are separated by either addition or subtraction. That's how we know how many different terms are in an expression. They're separated by addition or subtraction. Those are the only things that separate terms. Multiplication doesn't, division doesn't, but addition and subtraction separate the terms in an expression. So remember, when we do the beginning of the notes, sometimes it's like, I don't quite know what you're talking about. I don't quite know what this means, but rest assured we will go through examples of all of this so that it'll make sense. And then you'll have a reference when you're looking back. Okay, so last one on this page. To identify different terms, we will always rewrite expressions as a sum of the terms. So we're always going to add all the terms together. Even if they have a negative sign, we'll change it to plus that negative term. And I'll show you what this looks like when we get to our examples. It's a lot of vocabulary in this first section just because being able to do this and being able to work with these expressions requires a lot of vocabulary. So you'll be asked, identify the terms, identify the like terms. And so we have to know what that means in order to be able to do this section. So bear with me. It's a lot of vocab to start. But then we'll get into the actual practice and how to do it in a moment. All right. Couple other quick vocab terms, and then we'll pause for a little bit. Coefficient. So look at this word. This is an important word. This is going to come up a lot. I will use this word a lot in this section. Coefficient. The coefficient is the number in front of a variable. And when we use a coefficient, it means we're multiplying. So, for example, 5, if we have that expression 5x, the coefficient is 5. It's the number that's in front of the variable. Does that make sense? The coefficient is the number in front of the variable. Another example. What's the coefficient of that negative 10y? Caroline? Negative 10. Negative 10 is the coefficient. Well, we can also have fractions as coefficients or decimals. right? What's the coefficient there? Because 2/3. Yep, or 2/3. Okay, so the coefficient is just the number that comes in front of the variable. Coefficients will be important because they're how we simplify variable terms, how we combine them, add or subtract or whatever. The coefficients are what we use to do that simplifying. Did you have a question? Okay. Okay, and then like we said on the previous slide, a constant is what? What do we say a constant is, Charlie?
It's a number that can combine two variables.
It's a number by itself.
Yeah.
A number by itself.
Don't we already have that?
Yes, you don't need to rewrite this if you have it, but I just want to make sure that we have everything very clear for ourselves. A constant is a number alone without a variable. So notice up here, we have all these variable terms, right? We have a coefficient and a variable. A constant is just a number with no variable attached to it. Or -25, right? These are just constants. They don't have any variables, okay? We good with that?
Yeah.
Okay. Let's write our first example, and then we'll solve it when we come back. Okay, example 1 is going to ask you to identify the terms. So how many different terms are in the expression? And then it's going to ask us to identify what are the like terms in the expression. Terms and like terms, and this is our example. Once we have that written, we'll go ahead and pause. We said that we should change this all to addition so that we're adding all the terms together. So what we're going to do, let me see if I did this already. Okay, so step 1, rewrite as the addition of each term. So we're going to separate each of these terms by addition. And remember, any sign that's addition or subtraction separates terms. So we're going to rewrite as adding each term together. First of all, how many terms are in this expression? Can you see the different terms if they're separated by addition and subtraction, Kellen?
Is it 2?
No, go with your gut. What were you going to say first?
4?
Yes, 4. 1, subtraction sign that separates terms. 2, addition sign that separates terms. 3, this separates terms. 4. So there are 1, 2, 3, 4 terms as it's written, because addition and subtraction signs separate the terms, so we can see there are 4 different terms. Okay, now we're going to change this so that we can clearly see the sign that goes with each term by rewriting these as addition.
Do we say plus, negative, 2?
Correct. So here's how it's going to look. Notice how we put in a plus sign in between each term and kept the sign of the term. So 9x plus -2 plus 7 plus -x. And this is just so that we keep our signs straight, so that the negative sign is with that negative term, so that when we combine them, we remember to combine properly. Okay? But we're not quite at the point of combining yet. So first we rewrite as addition. And then the second part of this was to identify, so we could see now that we could see the 4 terms before, but if you couldn't see them before, 1, 2, 3, 4 terms in this expression. Step 2, how many terms total? What did we say?
4.
4 terms total. There are 4 separate terms. And then the last part of this asks us to identify the like terms. So that goes back to our first piece of vocabulary. Like terms, what did we say? What's our definition say? What is a like term? Dane?
Terms that have the same variable raised to the same exponent.
Very good. Terms that have the same variable raised to the same exponent. And the other thing that we said our like terms were what? Constants. Okay, numbers without a variable. So let's start with the variable terms. Let's find the variable terms that are like terms. What variable do we have in this expression, Charlie? X, right. See, if we're speaking in Espanol. Tenemos X. Okay, I'm going to erase those. So let's look at our X terms. Notice we have two terms that contain an X. Do you guys see that? Okay, in your notes, go ahead and circle the terms that contain an X. Which terms contain an X? 9x and negative x. These are like terms because they both contain an x and the x is raised to the same power. It's not an x squared in one and only an x in the other, or an x cubed in one and an x squared. They're both just 9x or negative x. So these are like terms, 9x and negative x. Lily. Doesn't matter if one's negative and one's positive. It only matters that they're the same variable, so they're both x, and they're both taken to the same power. Okay. What are my other like terms? What are my other like terms in this expression? Hazen? Negative 2 and 7. Why are those like terms? Finn?
Because they're constants.
They're constants. Constants are like terms. Okay? So we have our terms, all of them, and then we separate them into the terms that are like terms. All right? Oh, so 9x and negative x, and then our constants, negative 2 and 7. Those are our sets of like terms. We group them together. Good so far?
Wait, why do you need to... Sorry.
Okay. We are asked to do the same thing that we did in the previous one. Identify the terms. So how many different terms are there in the expression? And then identify the like terms in the expression. Okay, terms are parts of an expression separated by what? What signs separate the terms in an expression? John? Addition and subtraction. So let's start with the easy part. How many different terms do we have in this expression? Finn?
5. No, wait, 1, 2, 3.
1.
4.
Good. 2, 3, 4. Because terms are separated by what?
Addition and subtraction.
Addition and subtraction signs. So we have 4 different terms in this expression. Can you see that? Kellen, question.
Terms be separated by multiplication and division.
That's a great question. Can terms be separated by multiplication and division signs? No. Only addition and subtraction separate terms. Good question. Bridget.
Don't you have to make them all addition?
Yes, I'm going to do that next. In order to help us identify like terms, we're going to separate these all by an addition sign. So we're going to take our terms, we're going to say z squared, this is already addition, plus 5z.
Does the exponent go out of parentheses?
It goes in the parentheses. So the whole term, so we're going to say plus, in parentheses, negative 3z squared plus z. Now they're all separated by addition, and we can see the signs that go with the terms. Now remember, like terms, what was our definition? Go back to that first definition we wrote down. What are like terms? Addison.
So that have the same variable raised to the same exponent.
Okay, terms that have the same variable raised to the same exponent. All of the terms in this expression have the same variable. Would you agree?
Yeah.
But they're not like terms because why?
Because they're not raised to the power, because there's z not raised to any power, and then there's z squared versus raised to the second.
Good. So we have a z. Technically, you guys, these z's are to the first power. Just so that you know. We just don't put that on everything. If it's ever just by itself, it's always to the first power. But it's not to the second power. So they're not all like terms. So let's identify the like terms. What is one set of like terms, Hazen?
Z squared, z2.
Z squared.
Yeah. And 3z.
Yeah.
On 2.
Yep. Negative 3z squared. These are like terms because why? Why are these like terms, Ben?
They're
Good. They're the same variable taken to the same power. That makes them like terms. What is the coefficient of negative 3z squared? What's the coefficient of negative 3z squared? Oliver?
3 squared.
What's the coefficient? Dane?
3.
Bigger?
Negative 3.
Negative 3. The coefficient of negative 3z squared is negative 3. Just to reinforce the vocabulary. What's the coefficient of z squared? What's the coefficient of z squared? Oliver?
Just C.
What's the coefficient? What's the number in front of that z? Caroline? No. What is the this is good because we have to know this. John, what's the coefficient?
5z.
Nope. What's the coefficient of this term? What is the number in front of that z squared? Yes. There is an imaginary 1. Because how many z squareds do we have?
1.
1. So when there's not a specific number in front of it, there is an imaginary 1. There's 1 z squared there. It just doesn't say it. Okay? All right, so we've got those like terms. Erase that. Okay. Let me write those down here. So z squared, let's write that down here. We've got z squared and negative 3z squared. Those are like terms. What are my other like terms, Sam?
5z.
Good. 5z and z. What's the coefficient of 5z? What's the coefficient, Charlie? 5. What's the coefficient of z? Nicholas? 1. Very good. The coefficient of z is 1. We just don't say it every time. All right. So that's all we're doing right now is identifying terms and then identifying like terms. Like terms have the same variable taken to the same power. Bridget?
Will there ever be terms with no like terms?
Yeah. Yeah, there can be situations where you have no like terms. Or maybe you have one term, but it doesn't have anything else like it. That can happen too. Yes. Okay, moving on. Now this is where we're going to start combining like terms. Okay? Combining like terms gets us the simplest form. This sounds like fractions, right? We always have to have fractions in simplest form. We also have to always have our expressions in simplest form. So the simplest form of an expression is combining all like terms and not having any parentheses. Oh wait, I didn't mean to do that. Hold on. I'm going to erase distribute because we don't know that yet. We'll learn that later in the chapter. So you don't need to write this because it doesn't mean anything yet. I think, unless you've learned it. Okay, so combine like terms, and that means get rid of any parentheses that you can simplify. So you always have to, like order of operations, simplify within the parentheses. It doesn't mean you can't ever have parentheses, but it means you need to always simplify as much as you can with those parentheses. Oliver.
It's like order of operations.
So not the parentheses around the negative.
Correct. Yeah.
And this is like order of operation.
Yes.
And this is like order of
Yes.
operation.
Yes. Order of operations always. Always. Let's do an example of this. It says simplify, and then it gives, let's try this again. To combine like terms. This is important. I'm glad I put this in here. Okay. To combine like terms, this is why the coefficient is so important. Because we use the coefficient to combine like terms and to simplify expressions. So if we're adding or subtracting like terms, we add or subtract the coefficients. We use those coefficients to combine only the coefficients to simplify. Okay? So add or subtract the coefficients.
Put the number in front of the variable.
You don't need to put that. You don't need to rewrite the definition of coefficient unless you don't quite understand what it is. Then rewrite it so it keeps getting stuck in your head. 10n. So we're going to simplify this by identifying the like terms and then combining using the coefficients. So remember, this is the same thing that we were doing before. Change this into addition of these two terms. What does this look like if I change it to addition? Finn?
So you, like, for the negative sign, you make a plus.
So go 6n
6n plus.
plus.
Minus 10, or with parentheses, minus
Very
10.
good. Do you see how we change this to addition?
Yeah.
Okay. 6n plus a negative 10n.
Wait, do you need to? The whole
You will not need to do this forever, but this is helpful as we learn. Pretty soon you're going to figure it out that like you just do 6 minus 10,
Yeah.
right? But this shows us how to separate the terms so that then we can combine using the coefficients. Now we're just adding 6n and we're combining it with negative 10n. So what we're going to use is these coefficients of the variables in order to combine. What is 6 plus negative 10? Caroline?
Negative 4.
Negative 4. And then the variable just tags along. Negative 4n. So it's really just addition and subtraction, just making sure you're doing it with the like terms and using their coefficients. John?
So say, why do you have to do addition, but then it ends up as like...
The reason I do addition is because it separates the terms very clearly and keeps your signs with their coefficients so that you see it's a negative 10 and a positive 6. That's why.
And then later in the chapter, you can just do that.
At any point, you can stop doing that when you're comfortable with it. Okay, I just don't want you to lose the negative sign.
That's why we need
Correct. Finn,
that. So say...
I'm not going to take say theoretics. We're going to do more examples.
But
Just wait.
you're not gonna
Nicholas.
do this-
Can there be like 2 different variables on one question?
Yep. There can be 2 different variables. Let's see if we get one. No, not yet. We will. There can be 2 different variables in one question. You need to combine the like terms with the variables. But let's do this one. We'll do a few more examples so that we feel comfortable with this. Okay, negative 8.5w plus 5.2w plus w. We need to combine the like terms. First of all, how many terms are there in this expression? How many terms are there, Natalie? 3. There are 3 terms. How many like terms are there? How many like terms, Bridget?
2 or 3.
3. These are all like terms because they all have a w and they're all raised to the same power. What power is the w being raised to, Ben? Technically a 1. It's just not written there. It's imaginary 1. Lots of imaginary 1s. Lots of imaginary 1s is what we're learning today. Where else is there an imaginary 1 in this expression? Hazen?
Is it? Or wait, I don't know.
Okay. Vika, where's the imaginary 1?
In front of the double.
In front of the w, right? There's also an imaginary 1 right here. That's 1w.
Wait, there's imaginary 1. The exponent.
Yes, and the exponents, correct. All right, so we have 3 like terms. What are we going to do with these like terms? Charlie? Simplify, meaning what do we do with the coefficients? Yes, we're going to combine all the coefficients. Negative 8.5 plus 5.2 plus 1, right? That 1 in front of the w. Now I would like to add these first because then I can do the easy part, the same signs. 5.2 plus 1 is 6.2. Natalie, question.
Where did the W go at the end of the...
I'm going to add it at the end. So let's keep it out here so we don't forget because these are all going to be W, right? Then our last step, we have different signs. So this goes back to the very beginning of our year together where we have different signs. What do we do in order to simplify this? Oliver. What? Charlie?
Do the greatest absolute value.
Yes. Minus the smaller absolute value. So 3, 2. What will the sign of this be? Negative, because the larger absolute value was a negative. So our final answer is, if we simplify, negative 2.3 W. Don't forget that W. Because we can simplify it further. Noah, what'd you do?
I subtracted 15 minus
Very good. And what did you get? What's your simplified expression? 5y. Would it be negative? No, because why, Ben? 15 is the greater absolute value. Sophie. He just did this 15 minus 10. It's the same thing as saying this, negative 10 plus 15. Okay? Either way. Let's do another one. Don't worry. Big ideas, loves for actions. 3/8 b minus 3/4 b.
Does B stand for big ideas?
Ben. Very good. So because we are going to combine and we have different denominators, we need to get a common denominator. What would the common denominator be for these two terms? Kellen? 8. So this first one can stay the same. 3/8 b. And we're going to say plus negative, correct, 6/8 b. Now we can combine using the coefficients. So what we're really doing is 3/8 plus a negative 6/8. And then b will be on the end. All right, they're different signs, so we need to make sure we subtract in the way that makes sense and keep the sign of the bigger absolute value. What did you get, Hazen?
Negative 3/8.
Yes.
B.
Yes. Negative 3/8b is the simplified form of this expression. Okay? So don't forget, there's so many little rules that we have to always think about. What are the signs? Do I have a common denominator? How do I find the like term? So it's just, you have to be very systematic as you go through these problems to make sure you get every little part of it correct. Now I think this is going to go into your question, Nicholas, is if we have different variables. Okay, combine all like terms to simplify. So in these examples, they just gave us 2 like terms. We just simplified them. But what's going to happen if we have like 5y plus 10 plus 4y minus 7? Like, we have to identify all the like terms and then combine. For example, letter A, 3/4 y plus 12 minus 1/2 y minus 6. How many terms do I have in this expression before we get started? How many terms do I have total? Ben? 4. 4 terms. 3/4 y, 12, minus 1/2 y, minus 6. We have 4 different terms. Let's identify the like terms because we need to group them together so that we can combine. What's one set of like terms, Finn?
12 and negative 6.
Okay, good. 12 and negative 6. Why are these like terms? Why are these like terms, Bridget?
Because they both don't have y's.
Good. What do we call those, Nicholas? Constants. They're constants. Exactly. They don't have a y. They don't have a variable. They're just a number. They are constants. So we have 12 minus 6. That's our first set of like terms. What's the other set of like terms in this, Charlie?
3/4 y and negative 1/2.
Very good. 3/4 y minus, y minus 1/2 y. Now, we need to now combine the terms. So basically what we were doing in the previous examples, we have to do twice. Combine the y's and combine the constants. Yes?
Don't we change the signs to plus?
Yeah, let's change the signs to plus. 3/4 y plus negative 1/2 y plus 12 plus negative 6. What's going to be the easiest thing to combine first?
Constant.
Hazen.
12 plus negative 6.
12 plus negative 6. Super easy. What is 12 plus negative 6, Hazen? 6. All right, so we're done there. And then we have to combine our 3/4 y plus negative 1/2 y. What's the problem here? Before we can do this, we need to get what, Sam? Common denominator. What's the common denominator here, Caroline? 4. So we get 3/4 y. That one stays the same. It already has a 4. Plus negative 2/4 y. So now we can combine our coefficients. What do you get, Finn?
You get 1/4
1/4
y
y plus
plus
6.
which is 6 and 1/4.
No. Oh, I'm glad you said that. Is this 6 and 1/4?
No.
Why not? With a hand, why not? Braden,
Because we don't know what y is because it's a variable.
why can't we add those together? Because they're not,
Like terms.
yes, they're not like terms. Exactly. They're not like terms. Be super careful. I would say this is the biggest mistake that people make as we start to learn this is you want to keep simplifying, and that's great. You should always want to keep simplifying, but make sure you don't simplify where you can't. We cannot combine like terms. One is a constant, one has a variable. Those can't go together. Very good. Finn?
So you have something that has no like terms.
Then you,
And is that simplest form?
yep. If it has no like terms that can be combined, then it's simplest
Like
form.
say it's
You're done.
Z,
If it's like,
Z.
say z plus x plus y,
Yeah, Z plus X plus Z to the second power.
then you're done. You cannot simplify further. That's always nice when there's no fractions. Negative 3y minus 5y plus 4z plus 9z. How many terms do I have in this? How many terms? Natalie, how many terms? 4. Let's separate them by addition so that we can then combine easily. Negative 3y plus negative 5y plus 4z plus 9z. Give me one set of like terms. One set of like terms. Noah.
4Z and 9.
Good. 4z and 9z. Can you combine those for me?
13.
13z. Okay, what else? What's another set of like terms? Brady?
Negative 3y and negative 5y.
Good. Negative 3y, negative 5y. Can you combine those?
Negative 8y.
Negative 8y. And these are plus because that was positive 13. So then should I put these together and say that it's negative 21y? No, because why? Nicholas.
Because they have different variables.
Very good. They have different variables. These are not like terms. This is simplest form. We're done.
Yeah, are we done with this?
Okay?
I'm out of here.
But like, what if you try to solve it as a math?
You can't solve it. You guys, this is a good question. You cannot solve this. You aren't ever going to know what y is or what z is because there is not an equal sign. Eventually we'll get there. We'll have an equal sign and we'll be able to figure out what x is and or what y is and z is, but we don't have an equal sign.
We have big ideas.
Okay, Kellen. This is 7th grade math. We did it. We made it to 7th grade math.
If basically, so we did this at the start of the year.
I have a tool. Here's what it says. If W represents the width, where would I write a W on this exercise, Matt, to represent the width? Shh, Caroline. Across the top. This is the width. Where else could I write a W to represent the width? John. On the bottom. Right? These are the same. How am I going to write the length? What's the length? Charlie, what do you think?
3.3.
3.3 what? It's 3.3 W. Because why? Why is it 3.3 W? Caroline.
It's the width times
Yeah. Yeah. It's 3.3 times the width is the length. What else?
and to find the width.
Yeah, tell me. We have to write one more thing on our diagram.
So you have to wait. Can I say how to do it, or do we have to
Tell me.
write it on the other
Yes, and then tell me how to do it.
side?
So we're going to write an expression for the, so we would express the length, we did that as 3.3 W. And then how would we find the perimeter? which is all the way around the outside of the mat.
Divide it.
Perimeter. We're going all the way around the outside. Go ahead.
So you do the lengths plus each other, so 3.3 W plus 3.3 W.
Good.
And then you do that plus W.
Yep.
2W.
Yep.
W is
Yeah.
plus W.
Yes.
And then you add.
Good. And then you would simplify. I'm not going to, because we're out of time. We would simplify. We'd add all these. 3.3 plus 3.3 plus 1 plus 1.